welcome to Ladyada live from Brooklyn.
Hi, everybody.
First, it's a Ladyada from Brooklyn show.
That's right. We're in Brooklyn now. Happy Ladyada Sunday. Thanks for holding out. We were busy moving the company, moving ourselves to Industry City. We did a whole Ask Engineer show about it. So you can watch that recorded last Wednesday. It's on
Different
YouTube.
setup here. We're gonna be changing it a lot.
My left
We're
side.
gonna be changing it a lot. So you know, this is also kind of our live test with what we're doing
Yeah.
as well with all the different things here at Adafruit. We also had a big new product announcement and more, the RP2350. Ladyada will talk about that and more Ladyada. What is on your desk this week?
Okay, so I'm still like unpacking a little bit. So there's there's gonna be a little bit of like be flexible with what I got. But a couple things are on my desk that I've been playing with. One is I got the Vindy 2 PCBs. Liz is on holiday, but she'll be back next week. So on the overhead. This is a board that goes in the Vindricting Ikea air quality center. There's actually an Ikea Brooklyn, so maybe we'll go there. We'll check it out. What's this? Just goes into the board, and we had to update this design to use a USB connector. It really has to be right up against the edge here. If y'all remember, I did a great search a couple weeks ago on finding a connector that didn't have a little plastic piece, because usually there's a little plastic retainer. Even the little plastic retainer was, which we had on the previous version, kept it from fitting to the enclosure. Added temperature humidity sensor, fixed some pinout, put I2C over here so it wasn't in the way of the antenna. We thought the antenna was interfering with I2C. Turned out it was totally something different. But still kind of good taste to keep the antenna nice and clear. Using the S2 here because it's just low cost. The Vindricting board is a low cost air quality sensor from Ikea. We didn't want to make the add-on board be more expensive. In the back, some cute icons. We got the emoji icons using Penguin, and 4 LEDs. It was 5, but then we looked at the original Vindricting and it only has 4, so to match it, we got 4 here. So like I said, Monday, morning, as soon as Liz is back, we're gonna probably bring this up. It ought to work, and then we'll be able to get this design out the door. So it's exciting. Another quick design I did is we had the I2C to 1-wire adapter, the DS 2484. This is a similar board. I love recycling firmware, and our driver works with this. It's the DS 2482-800, which has 8 1-wire connections. So the 1-wire pin, and then the power pin, and the ground pin. You're probably like, wait a minute, why have 8 1-wire selectable connections when 1-wire is designed to be parallelized? You should be able to connect as many sensors as you want. The reason is, I think, why I would use this is, yes, you can connect multiple DS18B20 sensors in parallel, but then if you have a setup that's like replicated, so it's like more than one setup, and you have multiple temperature sensors, you have to use the ROM. You have to identify which is which, and the ROM code isn't written on the outside, so like you have to somehow pre-mark it. It gets like really weird, especially if you swap out the sensor. With this, you get 1-wire connectivity and 8 sensors, and you don't have to worry about like being able to identify them by ROM code. You identify them by what pin you're connected to. So I just made a small change to the library to make it work. With the 800, you just have like a select channel, and it's basically identical. Okay, and then the big news is, of course, that on Thursday was the release of the Raspberry Pi new microcontroller, the RP2350, which I've been working on, but I couldn't talk about, obviously, because it was a secret. The Pico II, which uses this chip and has 4 megabytes of flash. And then we also designed a Feather. You can sign up for these, are in the Adafruit shop for signups. We just got the real chips, so you don't have to like heat up. And also, we've been moving, getting machines set up and everything. It's gonna take a couple weeks, maybe a week or two till we get manufacturing, but soon. And then the Metro, which actually I'm gonna redesign. And I chatted about this on Ask Engineer, so I'm not gonna go into a ton of detail. except that, yeah, if we go to, I'll go to the overhead and I'll just show off the designs. So the Pico II, so this uses the A0 chip. So I actually have to either get new Picos or rework this to use the A2. The A2 chip, this says 68 pin, but it's actually a lie. It's the 80 pin. I just typed that. And then this is also A2. So the A2 chip is the latest ROM code update, and it's for the ROM mask update. And you can't, the latest SDK only works with the A2. So like you can't, I don't want to compile for the A0. So I had to rework a bunch of stuff. So the fact that I kind of like it because, you know, I designed it, but I also still like it. You got USB-C, battery, 8 megabytes of flash, PS RAM spot, so you could put 2 or 8 megabytes of PS RAM. And we do have PS RAM support. We did have it working in CircuitPython. The latest SDK broke something. We'll get it back up and running. STEMQT, SDK, sorry, SWD, and the power setup, which we'll talk about in a moment, because actually things change. You can see I have one inductor here and a different inductor here, but it actually turns out that this inductor was the better one to use. And then power switching circuitry, LED NeoPixel over here, and then HSTX, which I'm actually looking forward to. So HSTX is the new peripheral on the PS2350. So it's a Cortex M33, so it's like about twice as fast. It also has a proper FPU. Dual core, 150 megahertz. You can run an ARM or RISC-V. Honestly, the ARM has better performance and code size than the RISC-V, but it's cool that people can choose which to boot from. Twice as much RAM, like 200, sorry, instead of 264, it's like 200, 500, 2060, I don't know, 500 something something. 8K of that is one-time programmable. They sectioned it off. Secure boot, low power support, an extra PIO block, which means you now have 12 state machines instead of 8. So it's good because before it was like you would use one state machine for like USB or like 2 for USB, and then you couldn't use one for NeoPixel because NeoPixel tended to use PIO. So now you could have like USB and NeoPixel, or you could have like CAN bus and NeoPixel and, you know, something else. I don't know. The HXX is cool because you could also use it for NeoPixel, although right now the example code is for DVI output. So this is a 3-lane differential. So you got like data 1, data 0, data 1, data 2. So 3 data lines differential plus 1 clock line differential. So 8 pins total. Designed specifically for driving stuff like DVI displays, like very high speed, so you don't have to do the overclocking that you had to do to get DVI output from the RP2040, which did work, but it was like a little tacky. So now they have a peripheral specifically designed for DVI output, and we didn't want to put a DVI connector; it wouldn't fit. So instead, even like well, we probably could have gotten a micro, but I like the flexibility of having just an FPC because then you could bring it out. So the FPC connector we used the same pinout as the Raspberry Pi 5 DSi, because that's a 4-lane, so we just don't connect one lane. And then you have I2C also, which is useful because I2C can connect to HDMI and you can read what display you're connected to. 2 GPIO, also handy because HDMI has CEC and hot plug detection. So like those extra GPIO are handy. And then the 8 GPIO, and then a bunch of grounds. So the only thing is, how are we doing on time? How long is it?
You're 10 minutes.
Okay, so let's go quickly. So I just redesigned a breakout for now, and then let's go to the compy and I will show off. Give me a second. I have to show off the, where did I put it? I put it under dev boards.
I'll show cool photos.
Show some cool photos. That's, I gotta remember where the heck I put this stuff. I put it under, oh, FPC breakout. Okay. So I designed, I'm still thinking about this design. Now that I've got the breakout working, we verified that you can get DVI output from it, which is like sweet. I designed a simple breakout, just like loading. That'll take that FPC connector and give you a proper DVI, HDMI compatible output. The only thing is that I didn't use the Raspberry Pi 5 ordering of the pin because I wanted to route it easier. So I'm thinking about maybe redoing this, but I just booked the PCBs because, whatever. You have to do a little bit of work to get the HSTX connector, which is this, to work with DVI because you actually need a 5-volt signal. And it's like kind of like, do you really need it? And I didn't want to risk it, so I just put a 5-volt booster. You only need like 50 milliamps because you do have to power the EEPROM. Again, does it really need 5 volts? Probably not, but you only get 3 volts from that Raspberry Pi 5 connector. And then I squared C level shifter because you have to then shift. Not only did you boost up to 5, but now you have to shift down to 3, whatever. But this will let you do like, it should be inexpensive, because using all stock components that we use tons of, you'll be able to then plug it onto the, if you go to the overhead, the Metro or the Feather to get DVI output, which is cool. And then one thing is that, to redesign the Metro, and like it does work, but one of the problems is that like the Metro has significantly more pins than the Feather, and I also really wanted to have the micro USB, and I wanted the HSTX. And so we ended up doing a lot of like pin sharing, especially because the PS RAM uses like GPIO 8. And before you know it, was like there was a lot of pins shared. And also, I really wanted to have another couple analog outputs. And then when I designed this, there was only the 60 pin version, but then later, this is 68, but it's actually 80 pin. The 80 pin version of this chip came out. This is the B class. And so now that I have the chips in hand, I was like, before I release this, I should redesign it. So I've been doing a redesign. So you go back to the computer. I've been doing a redesign with the larger pin. It's the same kind of output. I also decided to go with a buck converter for the 5 volts to get like up to 3 amps of 5-volt output from like a 12-volt power supply. Still the HSTX, lots of lanes. There'll be lots of ground vias here. I do that last. USB-C. We had enough GPIO to do SDIO for the micro SD slot. So we could also use that. Sometimes you can get like a little SDIO to Wi-Fi adapter dongle thingies. So I don't know, that could be a possibility if you want to add Wi-Fi. PS RAM, spot, flash spot. Tried to give a lot of space because Scott wanted to be able to clip on like a little like Pomona clip. So hopefully I could maybe scoot this more, but it's tough because it's like this is right next to the power supply, which we'll talk about in a second. SWD connector, NeoPixel, and then another thing I'm going to do, I didn't finish, I'm still in the middle of routing, is I'm going to have 2 breakout pads. And so you could connect USB. I don't have space for a USB host connector. Here, it's tough. There's no more edges because I really like the DC power. I love the on-off switch. I think that's important. HSTX, is the size it is. USB-C, I need to have both boot and reset buttons accessible. I like the stem QT up the end, and then the micro SD. So it's like, where do you fit a USB host connector? You can't. So I'm finishing routing this. I've been routing this over the last day or two. How are we doing on time?
You're at minute 14.
Okay, great. Perfect. So the thing I want to talk about is for folks who are doing their own design for we'll publish this, of course. The Feather, I'll publish, and the Metro I'll publish if people have a working design. But one thing to watch out for, and like when I was working on the layout for, there's like published KiCad layouts, which is great for people who want to do open source, and mine will be Eagle, is super duper, like they like warned me like 5 billion times. They're like, by the way, watch out for that switchboard power supply layout, because this is the 1.1 volt core buck converter for the RP2350. That's the core voltage, especially if you want to do low current stuff. You'll want to have the not use an LDO, you'll want to use the switchable power supply. You do get a like slightly better performance for the low power. but you need to give it an inductor and some capacitors, and they're like, the layout is really, really, really important. And not only is it so important, but they're like, even the inductor is important. Also the crystal is important, but we'll talk about the inductor for the great search as we find an inductor you can use.
Where in the world is that part I need? The Great Search with Digii.
The Great Search brought to you by Digii and Adafruit every single week. Ladyada user powered engineer to help you. Yes, you find things on digikey.com. Ladyada, what is the Great Search of the week this week?
Okay, so this week, announcement release of the RP2350. Really excited. We love new chips, and Pico II are available at Digikey, but not the chips yet. The chips are still making it into distribution. So we'll probably do a great search soon about the RP2350 chip itself. But if you're getting excited, you want to get started designing your board, it's going to take you a week or two by the time chips are available. You can do it. One thing to watch out for is that the power supply, the switch mode power supply for the 1.1 volt core voltage is really specific. You need to like make sure that you follow the exact layout in the data sheet. And of course, you know, chips get released, data sheets are still under development. So we'll check that in a moment. So let's pop over to the data sheet. So this is the let me see this is the Raspberry Pi RP2350 data sheet as published now. I mean, it's probably, you know, if I refresh, it might be a new document. And this is, you know, layout information about the power supply. So the VN for the voltage regulator is 3.3 volts, and then there's this inductor drive. The switch mode itself is internal, which is great, but you do need a capacitor for the input buffer, output buffer, and the inductor. And one thing to watch out for is you actually even need, you really want one that has the coil moving in a certain direction so that you have like the field that's coming from the inductor going in a certain direction, which is like right hand rule, right? So, you know, they are working on inductor. Right now it's TBD. So they're working with Abercon to make a specific inductor, but there are some inductor, like, look, I'm not the Raspberry Pi Foundation, so I'm speaking a little bit out of pocket, but there are inductors that match these specifications that they said that you can definitely get started with your layout or your prototyping with while you're waiting for this special inductor to get released. And I'm not, you know, I've only made like 5 prototypes or whatever of my designs, but they did all work. So I don't know. I'm using these inductors that I've chosen. So let's look at the specifications. So the inductor must be fully shielded, 3.3 microhenries, no worse than 20% variability, maximum DC resistance of 250 milliamps, which is like not that much. So we find saturation current of 1.5 amps, not too worried about it. And you want it marked for polarity. And they, again, the TBD, not sure yet. So let's go to Digikey and let's search for the first part, which is the 3.3 microhenry. So let's look for, you know what, they don't like special characters, maybe. There you go. Okay, microhenry, U Henry. So we're gonna go to the fixed inductors. A lot of options. So let's, you know, 4,000 options. Let's start cutting it down and we'll get to the good ones. If we go only active, we definitely want 3.3 microhenry. We want, let's just click for active in stock. And let's exclude marketplace just so we, not that many marketplace, but that way we only get the one stock Digikey. Okay, we did hear the tolerance has to be 20% or better. So let's get over those tolerances. Some don't have the specifications in the Digikey datasheet, so let's just get the dash. We definitely want only fully shielded. I'm going to assume that the dash includes some that are shielded. Who knows? So I'm going to basically unselect unshielded and semi-shielded. So that maybe cuts it down about half. And let's just take a look real fast. Okay, looking good, looking good. Yeah, these are nice inductors. Okay. Next up, we only want surface mount. Cool. Let's look at that. We also want, we have a current limitation. Let's look at the current requirements. Least 1.5 amps saturation. So ISAT, let's look at 1.5 and above. Now, obviously, we have some limit of the size for the inductor. We'll do that later. So I'm not going to select everything because I don't need a 100 amp saturation inductor. It's not going to fit. It's going to be like enormous, right? So because the higher the current, the higher the inductance, the low, you pay, the size is the thing that grows. Looking good so far. Okay, next up, we can do sizing because the size does matter. It does have to fit. You want it to fit within that. So even it can be a little bit bigger, but you can't have this ginormous beast. Sorry, the DC resistance. We'll do the DC resistance, and then we'll do that. So the DC resistance, no more than 250. Thankfully, a lot of options. We'll select up to 246 milliohms. Basically, almost all of them are going to be that 200 options. We're doing good. 200 options, and they're looking nice. Nice. Okay. Okay. Next up, size. Right, that's the next part. So the sizing, they do mention the size. Let's find it. So they say 2 by 1.6 millimeters. Yeah, so the inductor's case is 0806 to 2016. I'm not like that big. It can be a little bit bigger. That is the smallest inductor they have. I'll select up to like maybe whatever 2.9 by 2.9. So we have a couple options. I'll say that this device supplier, some of them are dashes, but all the inductors are measured, so this is easier. All right, this gets us down to a nice 33 options, which is excellent. So let's see what we got, and let's sort by price. So some nice options. This one's pretty. I kind of like this impact version. One thing though is, well, let's sort by quantity available because that's another nice trick. I always like to sort by quantity. So this is the inductor I used on my prototypes. So let's go to the overhead. I'll show you the prototype. So the prototype. Okay, so here's the deal. So they're like, oh, use inductor with a marking. But, at the time when I got the Pico II, it didn't, they didn't have this requirement because this is back in 2023. So if you look at the inductor here, it's a unmarked, and this does look a lot like the DFE 2501. So it's unmarked and it is shielded. Drum core wire wound, and it's this is a nice inductor. So go to the computer again. So this is a little bit larger. This is a 2520, but it's got plenty very high saturation current, 2.3 amps, well within reason, wire wound, shielded. So I use this one and it seems okay. However, we do want to find one that's marked. And, you looked, I actually couldn't find one until I got down to, uh-oh, maybe I searched slightly differently this time. Uh-oh, hold on. Which one was it? Oh, you know what? Maybe I was pickier about the size. Let me undo my dimension. Could have been also marketplace. It was the. Can you check when I sent you the link? What was the?
You didn't send me the.
Oh, I didn't.
Yeah.
Okay, can you go to the overhead for a second? I'm gonna cheat.
Yeah.
I'm gonna look at my notes. So the inductor, which is used here, some kind of marking on it, was, oh, you're right, I didn't. Hold on, it's in my drafts. Okay. All right, sorry, can you go back to the computer. Okay. So this one, why didn't I see it? Oh, you know what? I think the size was a little bit, it was a little bit bigger maybe. Okay. This was the one that I ended up finding that did have a marking because I had to like scroll until because it's not a selectable option. So let me find again. So I was looking for surface mount, shielded, 3.3, 20%. Hold on. I'm going to find out why I didn't find this before. And in stock. And saturation current was 1.5 and above. Sorry, I'm backtracking to the scene of the crime. Why is this puzzle? Oh, I'm super mystified. Hold on. Shielded surface mount. Okay. Excludes, okay, exclude these. And then did I miss pick the dimensions? Sorry. Okay. Yeah, I don't know what I selected wrong. But it's here now. Oh, maybe it was the supplier device I selected by accident. Okay. So I ended up here, sorting by quantity. So the only thing is, like I said, there's not a lot that have a marking on them. This one actually doesn't have no, it doesn't have saturation. So this one is fine. But the one they had the most in stock of was actually this PA 4335, which is 3.3 microampere, sorry, 3.3 microhenry, 1.7 amp saturation, less than 250 milliohm max, surface mount. It's a little bit bigger. Like I said, I had the marking and the price was pretty good because it's like 15 cents in quantity. So this is my pick. This is the one I used on the bet on the Feather. Only thing to watch for is if you do you pick an inductor and it has the marking. Not only does it have the marking, but you have to make sure it matches the coil winding direction. So make sure that like the direction is counterclockwise when the dot in the top right corner. But hopefully, again, this Abercon special inductor will come out soon. All right. Thanks, everybody. Thanks for being patient with me. That's my pick.
Where in the world is that part I need? The great search with Digii.
Okie dokie. Thanks so much for joining us, everybody. We'll see you throughout the week. We have Show and Tell, Ask an Engineer, and then coming up, it's CircuitPython Day.
We're getting back into our groove. So probably by next week I'll be
We're back.
back. All right. Thanks, everybody.
Bye.